All right. Good morning. It's Wednesday the 15th, I want to say. Kind of these all blend together a little bit. I wanted to kind of cover a few questions that I've gotten sort of from people in office hours these past couple days and clarify like multiple ways to approach some of these sort of things. If you do everything that I was basically showing in the video and always use log base 10, great. That will work. Part of where I'm coming from is philosophically, I very much believe in like understanding all of why something's going to work the way it does. So there's some pieces that I in the video felt it's worth coming back later, but if you can do everything from the video, you should be okay. All right. This first one here is one of these ones on the logs with equations without logarithms. Now you could certainly solve this with logarithms, but I want to basically address this guy. This is number 21. This was on the recommended but not necessarily required sheet. The main idea is you've got to go through and rewrite all of these different pieces, these bases right here. And again, this might be a little weird with the 1, as some power or a base to a power. We need to basically rewrite all of these. So if you looked at some of the previous problems on there, it might have like a 3 and a 9, so you'd turn 9 into 3 squared and then use your properties from that point. Great. This one's a little bit weirder, okay? I'm going to kind of show you how we're going to approach this. If I take 6 and cube it, I get, 216. You can check that if you don't believe me, but here's the thing that I like about that. What that's going to allow me to do is take this 216 and instead write a 6 cubed. So now, if I were to basically build on that, weird, I'll do it in 2 steps. Think what this guy might be. 1 over 6 cubed is the same as 1 over 216. Oops, let's just do it this way. So how am I going to actually put that sort of work? Well, do you know another way to write 1 over 6 cubed? This whole thing is equal to, let's do it this way. All of those are equal, which means this whole right side over here I can now rewrite in a slightly different form. Let's change this color. I can rewrite this entire thing as 6 to the negative 3rd. And then if we build further off of that, how could I rewrite this piece, this 1 over 6 with the exact same base? Oh, that's not what I wanted to do. Nope. One over 6 is the same as 1 over 6 to the 1st. Six to the negative 1. Right, we know how to basically move those exponents around to basically clean any of these pieces up here. So I'm taking this now 1 over 6 right here, which is the same as 1 over 6 to the 1st, and I'm able to rewrite that as 6 to the negative 1 is what these guys are going to be equal to. So I'm going to move all this stuff over to the side. And again, this is just sort of the thought process. This is probably one of the trickier ones on there. If you get to that 21 through 24 problem set, you probably realize they get a little wild. I can now type this whole thing here, and I'm going to match up basically these colors. So it's going to look like this. Instead of 1 over 6, I'm going to write 6 to the negative 1st. And that was raised still to the 3x plus 2. So all I'm doing is changing the way that those numbers are written. I now have 216, which we established was 6 cubed. Let's put a parenthesis there. So I'm going to put 6 cubed here in parentheses because I'm replacing that 216, and that's still raised to the 3x. And then that's equal to 1 over 216, which we figured out was 6 to the negative 3rd. Again, you're going to see something probably not quite this wild on the quiz here, but the idea is I need to rewrite everything with the exact same base if you're doing one of these without logarithms. I've got a little bit of distribution to do here. I have a power raised to a power right here. So that's going to go in and multiply, and then this guy's going to go in and multiply as well. So what that's going to clean up and turn all of this into, that first term is going to be 6 raised to the, I have a -1 times all of 3x plus 2. That's going to give me -3x minus 2. It's basically a negative times everything. It's going to flip all of those. Then I'm going to have times 6 to the, I have 3 times 3x from these exponents right here. There's a 9x. Still equals 6 to the -3rd. I got one more properties of exponents that we still have to work our way through. I'm multiplying 6 to the something times 6 to the something on the left side. When we multiply the same base, you add the exponent. So if I add the 9x and the -3x, that's going to give me a 6x. So I can turn this whole thing right here into, shouldn't be negative, my apologies, 6x, because it's a 9 minus 3, and then minus 2. At this point now, since I have 6 to something equals 6 to something, I don't have to worry about those 6's. I can literally solve this equation. 6x minus 2 equals -3, can go from there. Okay, you can probably handle that. It shouldn't be too crazy. All right, next thing. This is from that same sort of problem set right there. Multiple ways to sort of approach this. I was talking with someone yesterday, and I asked, what base are you going to rewrite everything as? Because right now we see a 16, a 4, and a 2. I think this is like problem 22 or 24. Well, they suggested 16, because 2 to the 4th is going to be nice 16 to the 1st. Great. This first term, 16 raised to the 2p minus 3, is already written with 16 as a base. And then 4, I was curious. It's like, well, how are you going to handle 4 as 16 to a power? And they're like, well, it's just the square root of 16, so I can do 16 to the half. And I was, absolutely, yes, totally, that absolutely works, no problems. So they basically set up this problem and started to solve this guy right here by rewriting these two with 16 as a base. My brain generally says go to the smallest number. So I see a 16, a 4, and a 2, and all of those can be rewritten as 2 to the something. So I kept 2 to the 4, rewrote 4 right here as 2 squared, and then 16 as 2 to the 4th, and I'm just going to repeat that same process as on the last problem. They're really the same style skill, but it's kind of different ways of approaching it. The person yesterday who I was working with had some real good fluidity to realize, oh, I can write 4 as 16 to the half because it's the square root. Nice stuff. All right. I'm going to showcase now because I had a couple people asking some questions. Let's say that I started with this problem right here, just 4 to the x equals 16. I'm going to solve this sort of a couple different ways. And yes, you can kind of already see some of the work. This is me writing stuff at office hours yesterday. Right now, what most people are probably doing is sort of this right side here. We have an x in the exponent, so how do we undo that? We take the log of both sides. Now, I'm intentionally writing the 10 there. If you wrote log, so yours look like this, it now basically will match this process right here. That's fine. That's exactly what I was going over in the first video. It works just fine. There's no problems with it. If you don't see a number, we know that the number 10 is in that spot. So having it there doesn't make a difference. I'm just being very particular about some of that stuff, and you'll see why in a second. This exponent right here, we can bring down in front to make x log 4, which a lot of people go from this guy right here to that second step. Okay, sure. Be careful that the exponent goes over to everything before doing that. At this point, you would divide over log 4, and then you would type log 16 over log 4 in your calculator. It's going to spit out 2. Okay? What you're making the calculator calculate is log base 10 of 16 divided by log base 10 of 4. Those are not pretty numbers on their own. This means log base 10 of 16 means 10 to what power gives me exactly 16. Well, it's bigger than 1 and it's less than 2, but it's a weird decimal. 10 to what power gives me 4? It's between 0 and 1, but again, it's a gross decimal, but the product of the, or the division of these, quotient rather, is going to come out to exactly 2. I basically was talking to this other person, and I said, like, the way I look at this, I see a base 4. I want to undo it with a log base 4, because to me, that makes sense, right? Ways to work around this. So I was initially taught with sort of this left method here, where I would match the base. Couple reasons why, and I'm going to kind of approach this two ways. First one is, if I just kept it as is, repeating the same process, you'll notice parallels between both sides. Bring the x down. This piece right here, this log base 4 of 4, means 4 to what power equals 4? 1. So this part just goes away, leaving me with just this one. We can handle this guy mentally, right? We can figure 4 times itself how many times is going to give you 16. That's not so bad. The calculator doesn't know how to do log base 4s, so it tricks itself into doing this stuff down over here. This log base 10 of 16 divided by log base 10 of 4. It's a change of base formula. It's going to do that every time, and it's still going to come out the same. I don't care if you approach something from this view or look at it as I'm going to do just log of the argument divided by log of the base. You'll notice in this case the 16 is in the numerator. The base here, which is 4, used to be in the is now the argument of the bottom one. I'm changing this to 10. You'll see I'm saying here I could also change this to 500 base. I could change it to 7,000. It doesn't matter what the base is. That's the advantage of this word. I can put whatever number I want right here where this 500 is, and as long as it's the same for both, it works. Calculators have two types of logs, log base 10 and one that we'll talk about next week, which is going to be a log base E. So we'll get to that. I don't care which way you approach it. Another reason that I like doing the left way a little bit more, whenever I see a log base 4 next to a base 4, I just think these guys cancel. So what would be left? Just this x. I wouldn't even write this sort of thing at all, and we saw how it went away to 1. I would just go right to x equals log base 4 of 16, which if you track back to, like, what does it mean for a logarithm? How do we write something in exponential and log form? There was a slide that had, like, the green, red, and blue on it to match all the pieces. We're really just rewriting this form. That's all we're doing is changing it around. I have no preference to which way you use. It's fine with me. You do what you want. Now, where this came from is people were asking, well, how do we solve this guy right here? This log of, I think it's number 16 on the Math 3 Knowledge one. How do we solve log of 8 minus 6x equals 5? If a log undoes exponentiation, I had 4 to the x. My x is in the exponent. It's being exponentiated. How do I undo that? I use logs. What's going to undo a logarithm then? Exponentiation. What I basically do is I'm making these two pieces right here are equal. That's how the equal sign works. I'm basically saying I want 10 to the something equals 10 to the something. And as long as these somethings, these exponents are equal, it's still true. I could have 10 squared equals 10 squared, or I could write it as 10 to the 4 over 2. It's still the same value. The thing is, as soon as I do this, 10 to the log, remember this is log base 10, just like we saw in the previous problem, those pieces will cancel out. They undo each other. If I wrote it in a little bit cleaner form, this is basically what I'm doing. I'm taking the equation as is, making both of those pieces exponents with a base 10. The idea is this is a log base 10. What's going to undo it? Exponentiation with base 10. What happens at this point is I can cross out those portions, leaving me with just the 8 minus 6x. And what's 10 to the 5th? 100,000. You can finish solving the rest of that from there. This is the one right after it. I want to say 17. Well, I know 17 comes after 16. I believe, though, that was the previous number. A couple ways to approach this. I've seen some sort of cool fluidity with this. I personally would divide both sides by a 3 first to get log of x equals -1. And then remember, this is a log base 10. Let's see if I can sneak it in there. What's going to undo a log base 10? Exponentiation with base 10. So I can cross these out. That's going to leave me with just the x. It's going to remove everything else and bring it down. Well, and then my right side was 10 to the -1. What's 10 to the -1? 1 over 10. So I changed this problem for this person who was asking some questions to show, I should do it slightly differently. It's the same problem, except now I intentionally wrote in a base 20 to showcase this idea. If I have log base 20, again, I still divided both sides by a 3. You don't have to. I'll come back to how else you could do this. Then what am I going to do to undo a base 20? Exponentiate both sides with base 20. So this is 20 to the log base 20 of x. I'm going to pop on down. And then I have 20 to the negative 1, which is 1 over 20. I didn't end up writing it in there. There we go. If this was a 17, I would exponentiate both sides with 17 as the base, and I'm going to end up getting 17 to the negative 1. The process doesn't fundamentally change. In case you just want to sort of think for some fluidity of thought for this stuff, someone yesterday realized, wait a second, this is out in front, so I could actually bring this up and make it x cubed. And then they did the exponentiation and solved their algebra from there and did some cube roots. So they ended up having like a 10 to the negative third, and then took a cube root, which is going to give you a 1/10 sort of thing. So that also works out as well. I wasn't looking that way, but I think it's pretty clever. Oops, forgot to put a screen shade up here, so I guess there's sort of your answers for number 19. The main piece that I'm looking for, and it might have been a while, maybe even since 8th grade for some of this stuff, this guy right here is your initial value. It's how much you're starting with. This 3 is sort of your growth factor, how much you're multiplying by. So we're saying we're tripling. Really, we're looking to basically see, can you do a little bit of algebra with this? We give you 100,000 for the population, so we're just substituting. Divide both sides by 500. I have right here, again, I'm doing it, I'll do this both ways. I like, when it's a base 3, to undo it with a log base 3. I'm taking a log base 3 of 3 on both sides. When that happens, this piece right here, they're going to cancel out, just giving me t. I don't even need this stuff at the end. That piece that's highlighted is 1, which is also why it's basically gone. I would need to figure out what log base 3 of, got some extra writing from yesterday, log base 3 of 200 is. I'll show you how to do that in a second. Like, if you need to figure this sort of thing out, and you're like, my calculator can't do log base 3s, it absolutely can. What I literally want you to type for this is you're going to type, come on, log of 200 divided by log of 3. What you're doing is you're saying, and I'm going to add some things here that you don't need to worry about. Literally, if you want to know what this is, log base 3 of 200, type this guy into your calculator. It is that answer. You can take that number, take 3 to the whatever number it gives you, and hit enter, and it's going to spit out 200, depending on where you round some of those decimals. The way the change of base formula works is, I'll cover this one more time because I think it's pretty critical stuff. This number right here, 200, is the argument. Right? I'm trying to rewrite log base 3 of 200 into another form. 200 is still the argument of the numerator, and it's going to stay that way. 3 was the original base, and I'm saying I don't want that base to be 3. So we make 3 the argument of now the denominator. The argument's that piece inside of a log. We're allowed to now do this. What we're doing right here is we're basically changing the base. In this case, the number that's right here that we don't see is a 10. I could make it 4s where the yellow is. I could make it 17s. I could make it 3.5. I can make it whatever number I want. But we're going to do 10 because your calculator can do 10. There's one other number, the number e, which again, time travel 5 years ago and be like, we're talking about the number e, and your past self is going to be like, that's not a number, it's a letter. What are you talking about? Stop it. I get it. That's how the change of base formula works. If you just basically take log of the guy on the inside divided by log of the original base, it's going to give you your answer, and that's y. Okay? You could also, from right here, I imagine many people are going to do it this way, so I'll show you what that process would look like. People want to take just log, which if I say it on its own is base 10 of both sides. That's going to look like this. If you took the log base 10 of both sides, your first step should look like that. This 3 has that t exponent, so what are we going to do with that guy? We're going to bring it down in front. So it's going to look like that. What are we going to do next? I'm going to divide both sides by, let's see if it plays nice, log of 3, because I'm trying to get t by itself right now, and it's t times that. If I do this, what's going to happen here? Still on highlighter. These guys cross cancel, and you have to figure out what is log of 200 divided by log of 3. Hey, it's the same thing. Whichever way works. The left way is showcasing that you can have logs of whatever base, just like you can have numbers at whatever you want as a base. I don't care which method you use, whichever works. Most of the video was focusing on this, and that'll get you just wherever you need to go, no problems. I wanted to showcase this, and I mentioned on the initial video that I was going to. Here is just a little bit of spice for you. If you want to try something like this, I would highly recommend just pausing right here and working your way through it. Someone yesterday was just in office hours asking for some, I guess, spicier questions. So here's something where it was kind of going to combine a lot of properties of logs to basically solve some stuff. And I'm not going to solve this all the way, but you'll get far enough to the point where like we can autopilot the rest of the stuff here. First thing, I see this number out front of a log, I can bring that up as an exponent. Now, here's some of the nuance that I wanted to talk around. This 2 has to go to the entire argument of this log. That part's critical. That means what I have right here is 2x in parentheses squared, which is not the same as 2 and then x squared. I'm going to clean that up in the next step. I'm going to basically simplify my left side, which is 2x times 2x, which is going to give me 4x squared. Do you notice the difference, how the 2 was outside the parentheses? If I multiplied it out, now only the x squared has this guy because 4 is basically the 2 squared. We distributed it in law 3 from your properties of exponents. Now, the reason I wanted to do this is, since this is all inside right here, it's inside the parentheses of the log, I have log minus log. That's, I think, what is your third log property, which is basically when I subtract logs with the same base, I can end up dividing them on the inside. Log base 4 of, and you'll see I'm dividing both of these pieces. At this point, I've got log base 4 of a whole bunch of garbage equals 4. How do I get rid of this log base 4? Exponentiate both sides with a base 4. So I'm doing 4 raised to the log base 4, 4x squared over 5 equals 4 raised to the 4. At this point, those are going to cross cancel, or sorry, not cross cancel, cancel out, giving me just the inside, 4x squared over 5. 4 to the 4th is 256. You can figure the rest of this out, right? Multiply a 5, divide by a 4, take a square root. There you go. There's your answers, okay? You're going to see a Delta Math assignment come out sometime later today. I still need a second to kind of go in there and build it. Any of you EO6 retake people or Opportunity 2 people, whatever times you sent, those emails are scheduled to go out. I think everybody was selecting either noons or 11s. And then level 2 people are sort of tomorrow if you were for the first option for your level 2s. Those are set and scheduled and ready to go. Make sure you read the emails and follow those directions. We'll have your next test on Friday. I'm going to take another look at what that looks like and make certain that we're ready to go. You might see one more video with a couple of things coming out here. If you've got questions, please pop in office hours. The most I'm seeing is 2 or 3 people. It's very easy to ask a lot of questions, get a lot of quick clarification. And again, I want to hear how you guys are doing. I want to like see your faces, hear your voices. It's a weird time for everybody. Stay safe, stay healthy. Thanks, and we'll see you all soon.